going to go ahead and get started on this worksheet right here, limiting reactant stoichiometry problems number 2. Now, if you're watching this from home, you have a slightly different version of this worksheet in your packet. You want to print the version of this worksheet off that's below this video. It'll have this 2021 edition symbol in it. I edited this worksheet a little bit because I didn't think it was quite good enough to get us ready for our quiz coming up here on Friday, April 16th. So again, if you're listening from home, you might want to hit pause real quick, print off that worksheet below, or at least have it pulled up on another screen, something like that, so you can follow along on notebook paper. Now, so we have some limiting reactant problems here. I see one involving HCl and sodium sulfide, all this good stuff. Now, there are two things you should always do before you get started with your calculations. What are they? Right, yep, balance. We always want to balance. And the other thing would be, yep, fix those milliliters. So we want to convert all our milliliters to liters. So again, if you're at home watching, I'd go ahead and hit the pause button real quickly, balance, fix your milliliters, and then unpause before we get started. Now, if I'm balancing this guy here, I'm going to see, oh, I need more sodium on the right, so I plot the 2 here. I need a little bit, that gives me 2 chlorines on the right, so now I need 2 chlorines on the left. So I fix my chlorines with that 2 there. And then I see that my hydrogens got fixed all by themselves, so wonderful. So that's balanced. Then I'm coming in here, I see 47 milliliters, no thank you, 0.047 liters, 24 milliliters, 0.024 liters. Okay, so now we're ready to party. So in this particular problem, we want to know the volume of hydrogen sulfide gas. The volume of hydrogen sulfide gas. So all my calculations should be working themselves towards hydrogen sulfide. Can be prepared from these 2 different amounts of reactants. So if you remember yesterday, we talked about cheese sandwiches a little bit and bike frames and all that good stuff. So we can compare our amounts of sodium sulfide here, so this chemical here, and our hydrochloric acid directly because they have 2 different units. So we need to convert both of these into the exact same units, and then we can compare them directly and find out which one is going to run out, which one's going to hold us back, which one is the limiting reactant. So I'll start by finding the moles of both. I like to find the moles, or the first reactant I like to find the moles of is whichever one's listed first in the problem. So this equation has HCl listed first, so I'm going to go ahead and calculate that. So I have my moles of HCl. This is a solution. So the moles of a solution are the molarity, which in HCl's case is 0.34, times the volume. And notice I'm not going to accidentally put 47 here because I didn't forget to convert it into liters before the problem. Remember, you want to make sure you have no opportunities to use the wrong volume units. So just take care of that conversion before you even start your calculations. So 0.34 times 0.024 milliliters for your volume, or I'm sorry, 0.024 liters for your volume there. You'll find that you have 0.0082 moles of HCl. If I were to convert that into hydrogen sulfide, it's a 2-to-1 ratio between these 2 guys. So again, I'm getting this ratio from the 2 to 1 here. It's a 2-to-1 ratio, so I need to divide by 2. So I have enough hydrogen chloride to make 0.0041 moles of hydrogen sulfide. That's what that is really telling me. Let me go ahead and do a line of calculations for sodium sulfide. So my moles of sodium sulfide. This is also a solution. So I'll find this by multiplying the molarity times the volume, just like I did with the first one. I have 0.0047 moles of sodium sulfide. Let's do a quick pause here. Some people may be tempted to make this mistake where they're like, oh, okay, so this is 0.0082, this is 0.0047, this is a lower number, so this is our limiting reactant. Okay, but we do not want to do that. No, 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 no. Because these are 2 different units. This is, if I highlight, moles of HCl, these are moles of sodium sulfide. Those are apples and oranges. You cannot compare those two directly. That's why we need to get them both in terms of moles of hydrogen sulfide, the H2S, before we can compare. So watch out for that. Don't make that mistake. Okay. So if I want to convert my sodium sulfide moles into hydrogen sulfide, this is a 1-to-1 ratio now. And that means I have enough sodium sulfide to make 0.0047 moles of hydrogen sulfide. Now that we have two identical units, moles of hydrogen sulfide for both our reactants, it becomes clear, oh, this is a smaller number, and therefore that's our limiting reactant. On quizzes and tests, I really want you to label the limiting reactant really clearly. Notice I've done that with two giant capital letters, LR, exclamation mark, exclamation mark. That way Mr. Pilcher has no doubt in his mind whether you understand which which reactant is holding you back, which one runs out, which one is the limiting reactant. Well, so it looks like HCl is going to run out here, so we need to find out how much hydrogen sulfide we can make once our HCl runs out. Well, again, we were asked to find a volume of hydrogen sulfide gas. And so if I come over here, I'm going to set my moles of hydrogen sulfide equal to the volume in liters over 22.4. I'll then multiply both sides by 22.4 to get volume by itself. And I should find that this is, let's see here, 0.092 liters of H2S gas. And of course, I'm a model student, so I'm going to go ahead and put a box around this guy right here. Boom, boom, boom. 0.092 liters of H2 gas. And so that's a wrap on problem number 1. It's a great preparation problem getting ready for your quiz on Friday. Now, a couple of things. You'll notice that these problems tend to get more difficult as you go through the worksheet. If I flip to the back of this worksheet looking at problem number 4, these questions, they're asking you about the same topic, but it's a little bit different angle sometimes. So here we have an acid-base reaction, neutralization reaction. So remember, when we say an acid-base neutralization reaction, we're referring to the idea that when you have the same amount of acid and base, they neutralize one another, they kind of cancel one another out, and your solution is just neutral. So for example, pure water is perfectly neutral. And so this question is asking you, will the final system be acidic or basic? In other words, if the base runs out, it's all used up, that means there's a little bit of acid left over, and the system will be acidic. Or vice versa, if all the acid is used up, that means there's a little base left over, and the system will overall be a little basic. And so this question isn't asking which one of these do you run out of first. It's which one of the reactants do you have a little bit left over after the process. So the calculations will still be the same in a lot of ways, but it's a little bit different angle of looking at the same topic. Now I'll let you figure out this problem on your own. Of course, we want to start with our balancing and fixing our milliliters. Hint, hint, nudge, nudge, wink, wink. And you can go ahead and check the answer key below, but I strongly encourage you to really try this problem for a while and struggle through it before looking at that answer key. So please keep that in mind and let me know if you have any questions. Alrighty, folks, that's a wrap for this worksheet. Get cooking on this. Make sure you knock this whole thing out before you get to that quiz on Friday. I'll see ya.